Okay, so as I was saying earlier, the BIOS, let me just repeat that BIOS part so everybody can understand. What BIOS means? BIOS means basic input output system. Okay, now, when you buy a system for the first time, the motherboard of that system always have what they call a BIOS stroke UEFI chip. Now, what does that mean? Let me explain. The BIOS keeps every details of this entire board, every information about this entire board we're seeing today. The details of the what kind of board it is, the components, all the details of the components. That is what this chip is. It carries that information. So when you assemble your computer and you power it on, the first place you go is the BIOS to see the configuration of the entire components you have. So BIOS keeps the information, the firmware information, the companies that produce the parts you have on your board, the configuration of the board or of the system. Let me just put it that way so I don't confuse you. So that is what the BIOS did. Now, what they did was, BIOS is used to help to boot the computer. It's the one that gives instruction to the computer to boot and manage the flow of data between the hardware, video card, keyboard, mouse, and more. So in modern computers, BIOS has been replaced by UEFI. Now, the UEFI specifies a different firmware for boot and runtime services. Firmware is programming that allows a computer operating system to control the hardware. So now this is it. When you buy a system for the first time, what you're trying to say is, there are some, you don't hear that name, BIOS. You hear UEFI. It's still the same thing. The difference is the UEFI puts more security on the system, meaning they make it more, how will I put it, more branded. Like, for example, when you buy HP use all the time, they use the UEFI to make you feel they have branded that system. You cannot even have access to it at all. When you on the system for the first time, or you on your laptop for the first time, you see that it only boots to that UEFI environment. It does not give you access to see the BIOS. So the UEFI is more like a smaller operating system built for organizations to control the BIOS. I don't know if I'm making sense with what I'm saying. If you buy HP today, right? You on your HP system, you will see it display HP, right? Before now, when you on a computer system, it doesn't display HP. It gives you a set of information, like something coming black. If you bring a black screen, you'll see some codes coming out. The system is booting, actually. Yes. So yes, that thing you're seeing there, they are the BIOS. But what HP and all this organization did that, hey, we don't want people to be seeing all this information. It doesn't make, let's do something. Let's have an operating system, our own operating system, that when they boot, it will just see us directly. It will see us, HP. Some will give you information like HP and the name of the laptop. That is a UEFI. So you cannot see the information as an engineer. You went to buy a laptop. For you to see the information, you cannot see it. The only way you can see it is if you go into the BIOS. But before that time, before now, the BIOS itself, when you're on your computer, you already see the configuration. It will show you Pentium this, and it will show you Intel systems, so Pentium, this hard drive, it will be telling you as it's booting. But because these guys have introduced that UEFI, you cannot see all those information again. Except as an engineer, there is a code you press on the keyboard that takes you to the BIOS, where you now configure. So that is how it is. That's the work of the BIOS. So let's proceed to the next. So let's go back to the SATA. So I can talk about the SATA again. Now, the SATA, like I mentioned earlier, is a serial advanced technology attachment. Now, it is a disk drive interface. What does that mean? The communication between your hard drive and your motherboard is the SATA. That's what it means. The SATA cable is plugged into this cable on the motherboard. Then is now connected into another slot in your hard drive. That is the communication. So the work of SATA is to bring communication between the motherboard, okay, the motherboard, the CPU, and the motherboard, the CPU, and the hard drive. Now, don't forget that motherboard, the word mother, is the mother of all the boards. It keeps all the communication between all the components in the computer system. And that is why it's called the main board or motherboard. So every component on that board has to communicate with each other. And how did that happen? Through different connectors and expansion slots. And through those connections, those expansion slots, those internal USBs. So all these things you see are connections that will be connected. They have their own cables that connects you to the main device. If it doesn't have a cable, it has a card that will sit. So when you buy a board, your RAM slot is empty. Your internal USB connection, there is nothing connected to it. Your chipset, that one is, it comes with the system. Okay, it's like a processor. It's like a CPU, but it's not a CPU. Now, a CPU slot, which is called CPU socket, there's no CPU inside. It comes empty. So you have to buy your CPU separately. Then you have those expansion slots I mentioned to you. Different types of expansion slots you want, how you want it. Okay? Then there's what they call a small battery. There's a small battery here, which I'm going to, let me Google it. So like I want to always show you some of those things on the internet. So let me show you. They call it CMOS battery. Now, can you see it clearly? Let me pick up. Okay, let me pick up this diagram. Can you see my diagram clearly?
Yes.
All right, good. Good. Now, this battery you see, as small as this battery, if it's missing from your motherboard, your system, your computer system will be resetting to the factory date. Please, let's mute this thing so we can hear. Your computer system will be, it will be resetting. If this battery is not found on your system, when you on your system, let's say you on your system for the first time, your system is showing the manufacturing details. They'll tell you the system is being bought on so set it and do all those settings. Now, if this battery is missing on your motherboard, or this battery is low because it always it's like a normal battery that you put, and sometimes it's expired, then you have to replace it. Anytime you on your system will go back to the manufacturing date, and you have to reset it again. When you reset it again, as long as this battery is not there, it will keep resetting anytime you power off and power on. So the work of this battery is to store information, is to protect and store information that you have saved in your BIOS setting. That is why this battery is there. They didn't mention it in there, but I needed to explain it further because many people have that problem a lot. Okay, so do you have any question before I proceed?
So the battery, is it is also in a laptop? Is this
yes, it's on a laptop. It's always on every board, every motherboard, because the work of that battery is to keep saved information of your BIOS. For example, now the default setting of the BIOS says my system should boot from a particular hard drive. Now I want to set it that my system should boot from a different drive. My system should have a different date. My system should work. I want my system to have a Canada date or something. Or I want to configure part of the devices that I've bought. I want it to work perfectly. So I did my own setting apart from the default setting from the system, because every system has its own default setting. You can always go and set the system to your own taste. So when I set to my own taste, when I save what I've set, the battery, because the battery is on the system, it keeps the record that I've saved. But if the battery is bad or the battery is not okay, it will not reset. So most times, this is a secret of most engineers. When your system has a problem and you call an engineer to come fix it, most times when the engineer sees what you're going through, oh, okay, maybe there was an hard drive, there was a communication between the datas and all that. The only thing he will come and do, he will come and remove this battery. When he removes this battery and put it back, the system will reset to the default setting and your system will start working again.
Please come again.
Most times when you have a communication issue with your system is not booting well, if you boot, it will hang. Most times it's always a communication issue, meaning maybe your system has been on and off and on and off and on. So some of the caches and some other RAMs or physical RAMs have been having some issues. Now, when an engineer comes on board, the first thing an engineer needs to do to resolve the problem first is to take out this battery. You can see it there. You take out the battery, because once you take out the battery and power on the system will reset back to the default setting, the factory setting. Okay? And when you reset back to the factory setting, you put back the battery. You can now reset the system back, excuse me, to the normal position. So most times when your system has a problem like that, the first thing an engineer does as an hardware engineer is to take out the battery, restart the system, and put back the battery. So whatever problem that is hanging, whatever communication that is ceasing, the system has been reset back to factory setting. Then from there, you can start troubleshooting. So all these things are what we're going to do when we get to the troubleshooting part of the class. How to troubleshoot. Okay, so in those process of how to troubleshoot, you will learn all this process. Okay, so let's don't jump. Let's just continue the way. I just want to mention it to see how important the battery is. Okay, so which other question do you have? Any other question so we can proceed? All right, let's proceed.
No other question for now.
All right, let's proceed. Now, please, I need us to listen very carefully this part. Listen very carefully on this part. Motherboard component connections, how the connections of the motherboard works. Okay. We have the PCI Express Graphics slot. We have the NOT bridge, we have the CPU, we have the hard drive, you have the south bridge, okay? Then you have the adapters, those are the expansor slots. You have the 32-bit PCI slot, 32-bit PCI slot, another 64-bit PCI, another 64-bit. Then you have the keyboard, you have the BIOS UEFI, and you have the RAM. This is the architecture of the motherboard. This is the connection of the motherboard. This is a diagram. So this diagram is showing us motherboard component connection. How are they connected? It starts from the CPU, right? The CPU is connected to the NOT bridge. The CPU is connected to the NOT bridge, right? The NOT bridge, when I mean the CPU, you already understand what I said. I said it from the beginning that CPUs are not system units. They are small components. For those that are just coming in, let me just show you the diagram again. So we don't mix. This is a CPU. Okay? This is what I call CPU. This is a CPU. If you're seeing my screen, this is a CPU, okay? So when I'm saying CPU, this is the processing unit. And we're still going to talk about the processing unit. But this one is a system unit. Now, it's called a system unit because all the components are inside already. Okay? So it's not called CPU. I always say it's not called CPU. It's a system unit. Okay? And it's called system unit. And I'm going to show you now so you understand that it comes with a diagram. You can see it. It's a system unit. This is it. Okay? The components, everything is inside. So it's called system unit. When the components are not inside, it's called case. Okay? All right. So let's go back. So the CPU is connected to the NOT bridge. The NOT bridge has connection. The PCI is connected to the NOT bridge. The RAM is connected to the NOT bridge. Okay? Why the BIOS, UEFI, keyboard, USB is connected to south bridge. Hard drive is connected to south bridge. All this PCI is connected to south bridge. Now, please listen to this part. As an engineer, okay, or as a technician, IT technician, okay, first thing you need to know is to understand the flow of the connection. So when somebody comes to you and say, hey, I have a problem with my hard drive, you don't go to the NOT bridge to start finding the problem of an hard drive. You go to where? To the south bridge. Am I communicating? Now let's look at what this means. The figure illustrates how a motherboard connects various components. Most chipsets consist of the following two types. They have the NOT bridge and the south bridge. Those are the two key parts of a motherboard. So what does that mean? It means a motherboard has two parts. As a motherboard, it has the NOT bridge and it has the south bridge. So a NOT bridge controls high-speed access to the RAM and video card. It also controls the speed at which the CPU communicates with all of the other components in the computer. Video capability is sometimes integrated into the NOT bridge. Now let's look at the South bridge. South bridge allows the CPU to communicate with slower speed devices, including hard drives, universal serial bus, USB ports, and expansion slots. So, looking at this diagram now, I want to ask a question. Who is the brain or the lead of this whole connection?
CPU. CPU.
Correct. CPU is the lead. That's why you see it is the first, is the lead. So CPU is like the president of the community. CPU is like the president of the community, of this community, sorry. And it controls everything. But how does it control? It doesn't control directly. It has to communicate with either the North bridge or the South bridge to reach out to the other components. I don't know if you are getting my point, because you need to understand this part as a technical person. Once you have this understanding of how this works, then anything concerning troubleshooting is easy for you. Even if they bring a motherboard, tell you the problem, from where you are sitting, you can give them the answer. You just ask them, what part of the are you having problem with? It will tell you. You say, okay, you already know that problem is from the North bridge. So what are the problems from the North bridge? We're going to see that. So the North bridge controls high-speed access to the RAM and video card. It also controls the speed at which the CPU communicates with all of the other components in the computer. Video capability is sometimes integrated, okay, into the North bridge. So South bridge allows the CPU to communicate with the slower speed devices, including hard drive, universal serial bus, USB ports, and expansion slot. If you have any question, please do let me know before we talk about the form factors of motherboard. Any question? Can you all hear me? Any question?
No question from my end.
All right, so we all understand. Okay, good, let's proceed. Now, what is a form factor? Can somebody tell me what a form factor is? What is a form factor?
From the size, we can also say maybe the size of an hardware.
The size of the type of an hardware.
All right, good. We all understand it. So let's move on. So the size or the type of motherboard. So why is this important? It is important because every motherboard has its own specifications. Like I told you, different sizes, different functions, different speed. So let's look at the sizes first. An ATS, which is an advanced technology extended, most popularly form factor, is the most popular one, which is 12 inches by 9.6 inches, 30 centimeters, 30.5 centimeters by 24.4 centimeters. That is an ATS. So we have an ATS form factor, size of a motherboard. Then we have a micro ATS. A micro ATS is the smaller footprint than the ATS, popularly in desktop and small form factor computers. It is 9.6 inch, okay? And it's 24.4 by 24.4. Those are the smaller ones. Then you now have another one that is smaller than that micro, which is the mini ITS. The mini ITS is designed for small devices such as thin clients and set-top boxes. I'm going to show you a diagram so you can understand what we're talking about. Let's look at the thin clients and see how the thin client functions. Can you see a thin client? So this is what they're saying. This is what they're talking about. It's always like this. There is a board, okay, inside as well. So they're trying to tell us that the board inside here, okay, they're telling us the board inside there is a mini ITS, okay, designed for small devices. So we have the last one, which is ITX. So it's comparable form factor to a micro ATX. So let's check it out. You can see it. Okay. So, all right. So these are the boards. They're always smaller. Okay. You can see mini ITX motherboards. They're always smaller, very tiny. This is another one. Can you see the diagrams I'm showing you?
Yes, yes.
So this is, so they're always smaller, and you find them in most organizations where they keep them. They always look like even smaller than the thin clients. And they're very expensive. So let me don't show you the part where. Okay, so let's go back to the. All right. So let's look at it. A form factor of a motherboard pertains to the size and shape of the board. It also describes the physical layout of the different components and the devices on the motherboards. So we have the advanced technology extended. What does it do? This is the most common motherboard form factor. The ATS case accommodates the integrated input and output ports on the standard ATS motherboard. So the ATS power supply connects to the motherboard via a single 20-pin connector. So that's for the ATS. So let's look at the micro ATS. The micro ATS says this is a smaller form factor that is designed to be backward compatible with ATS. Its micro ATS boards often use the same NOT bridge and sub bridge chipset. What's going on? Systems. Hold on. A minute, please. I don't know, my this thing is. What's my all right. Can you see the screen now?
No.
Just a minute, please. I don't know why my Google Chrome is just closing. Let's close the second time. Okay. Okay, can you see it now?
Yes.
You can see it now, right?
Yes.
Okay, good. So the micro ATS, this is a smaller form factor that is designed to be backward compatible with ATS. So a micro ATS board often use the same North bridge and South bridge chipsets, okay? And power connectors are full-size ATS boards and therefore can use many of the same components. Generally, a micro ATS board can fit in standard ATS cases. However, micro ATS motherboards are much smaller than ATS motherboards and have fewer expansion slots, okay? So we already know what the expansion slot means. So what they are trying to say, the smaller the motherboard, the smaller the expansion slot. That means if they have 4 expansion slots, meaning you can have 4 cards on your ATS. When you come to the micro ATS, you might just have only 2 expansion slots. Okay, so we have the ATS. The ATS form factor has gained in popularity because of its very small size. There are many types of ITS motherboards. However, the mini ITS is one of the most popular ones. The mini ITS form factor uses very little power. That's why a lot of people go for it. It uses little power, so fans are not needed to keep it cool, like the other big ones. A mini ITS motherboard has only one PCI slot for expansion cards. Now, this one has only one expansion cards, one PCI expansion slots, for expansion cards. Then a computer based on a mini ITS form factor can be used in places where it is inconvenient to have a large or a noisy computer. What they mean by that is when you don't have space, okay, you go for ITS computer, so or motherboards, or you buy the ITS, the system and everything you could assemble for someone. You can use an ITS technology to create it because it's not going to take more space. That's what they're trying to say here. So it is important to distinguish between form factors. The choice of motherboard form factor determines how individual components are attached to it. This type of power supply required and the shape of the computer case. So manufacturers also have, okay, now what they're talking about here is when you're about to assemble a computer, okay, you must consider 2 things. The size of the motherboard you want to buy will determine the size of the casing you want to buy. So that's what they're trying to say. So before you draw your plan, you can draw your plan. Okay, you want an ITS. So if I want an ITS, I need to buy an ITS case. I don't need an ATS case. So before you buy your case, you must first know the kind of motherboard you want to buy. So most of these motherboards can fit into an ATS because ATS is bigger. ATS case is bigger. But if you're buying an ITS case and you want to buy an ATS motherboard, it's not going to fit in because an ITS case is smaller. That's what they're trying to explain here. Okay. So if you have any question, please ask before we do this.
Question.
All right.
The question, all these things you are explaining, most ready-made, like if they are going for ITS, they buy the whole component, like ready-made. But what you're explaining is like possibly if you find yourself in a situation whereby you are working where they assemble, where they assemble hardware.
Mm.
So I think this lecture,
No. Okay, let me explain this. Don't forget that you are learning.
because I've never seen a firm or someone that will just go and be buying spare parts of hardware and assemble it together.
No, a lot of people do it. If you work in an organization, they do it a lot. If you work in an organization, right? Now,
Yes.
don't forget about you are an IT. You're actually an IT technician. You understand?
Yes.
As an IT
Yes.
technician, you should understand how to create, not to buy ready made. It's just like you are a tailor. You now want to go and buy a agbada that is sold already. You understand what I'm saying?
Yeah,
a tailor won't do that. A tailor will buy material and sew the cloth from the ground and wear the agbada. You understand? So that is how they see you as an IT person in an organization. Now, in some organization, there are some organizations you work with, right? They will tell you they don't want to buy red meat. You are the head of the IT, and you're going to buy all the board, you're going to buy all the casing, you're going to assemble, because they don't want what those people want. They want something higher. So red meat may not give you the kind of